Hello everyone. I wanted to show you how far I've gotten on my C# coding for Starship Mover. Added a background and we got some more scripts that are going to be able to track health. So here we have our health and we have public variables that are able to be adjusted in the inspector window, like how high the health is. We have private variables that are referenced later on for current health to see. We can set it to max health at the initiating start of the game. And we have a death component that can call on our actual abstracted class, or it calls on our child class from the abstracted class. So we can see here that we're storing our health information, setting it to 100. We're going to check later on when we actually take damage. This is going to make sure that we don't run with errors, so it's actually checking to see if it has the death component. We're going to show here how our debug log is actually able to reference how much damage it's taking, who's taking the damage. If the object gets destroyed, it's going to throw up the debug log that this game object that it's assigned to, we have it on our starship for now, is going to say that the starship died. But if we had it on something else, it can say like the asteroid died. So this is actually storing the information from our max health, showing current health. And so this will give us what max health is going to be when we start the game, once it takes damage, how much the actual current health is going to remain to damage. And as long as it's above 0, it's not going to throw the next line of code. But if it is 0 or less than 0, then it's going to show that it dies. So this is all able to keep and store information in this health with referencing our other two classes for Death Destroy, which is the child class, and Death, which is the abstract class that we're using abstract void class die. And that'll give us the public override, which destroys the object. It'll take it from hierarchy and everything that's assigned to it, like controllers, just to get rid of any errors. Because we don't want the game to run with errors. So if it doesn't have die, and if it doesn't have these specific requirements, like current health equals 0, then it's not going to reference these. So we'll double check to make sure that they have those before we start. So like here, if the death component does not equal null, which is nothing, then the death component can die. If it doesn't, it'll reference an error. So if I don't have health assigned to my asteroid and I hit it, it's going to throw up an error message. Instead of destroying it, it's going to throw an error message because it doesn't have health. This is just going to make sure that it doesn't have the death component on it. So then it's not going to throw any error messages. This is just make it so our game doesn't break when we start hitting stuff that's not supposed to be hit. And then here we have two instances of an asteroid. This asteroid, its instance is to kill once we touch it, and then this one will just start taking damage or start assigning damage to our spaceship and depleting that health by level of 10. We're actually able to adjust how much damage it does through this damage amount. So we can set it higher so it only has to hit it a couple times to get destroyed. But then we can have like this one later on where it's moving, and that will give an instant kill because it's giving more force. So it'll just be more of a realistic expectation. This is a reference to instancing on our program. And it works by using these colliders. So this green box that comes around here are actual colliders that we can see. Like even our starship, we put a collider on this one using the collider. So as these lines intersect, the Unity is able to keep track of which ones cross over each other, and they can perform certain other actions like take damage or not. And if we have them as just colliders, they're just a box to reference to Unity to perform action. If they're triggers, then they can overlap each other. It's not going to stop the colliders from hitting each other. It's going to allow them to pass through each other, but they can create certain hitboxes that will allow us to like maybe play a cutscene, or that's what instructs sound to play. But it allows the object to pass through it on a trigger and doesn't allow it if it's not a trigger. It's just a bounding box that prevents them two from intersecting. So some of the key principles like abstraction, we'll set certain things to private that we don't want the programmers or players to be able to mess with until our code is actually ran. So like current health, if it's at max health, I don't want them somehow able to adjust current health to an unreasonable number. So we'll set them to private so it can only be instanced through certain things. We use another term which is encapsulation. So like all of our health is assigned into the health. All of our player control is assigned into player control. So everything that we need for that object to work is encapsulating. It's self-contained and able to be not referenced. I don't have certain health components in my death. I don't have anything that I need to play with my player movement here in death or damage on hits. It encapsulates everything that the code needs to run within one script instead of spreading out a bunch of different scripts with all my information in it. And for inheritance, we can see here, like on our player and pawn, they can reference each other and talk to each other and take certain variables from each one. Same thing with our abstract classes here. They're inheriting from this public class void, which is die. And then to define what die is, we're coming in here, we override it and we destroy the game object that this death destroy script is assigned to. So this is a version of inheritance. It inherits from mono behavior, even though it doesn't say it here, it's referencing death, which still inherits from mono behavior. So they all kind of talk to each other when we are able to inherit from either a superclass down into a subclass. And we use the last pillar will be our polymorphism. So like on this, when I actually come in to play the game, we can actually see everything run now and we don't have errors. If I come over and hit this asteroid, I start hitting it. I take the starship takes damage at 10, and my remaining health on the starship is 90. If I started adjusting these to hit even harder, to where it's hitting now a damage amount of 50, because I'm doing this in the actual player, it's not going to save this variable at 50. It'll still save it at 10. But now when I hit it, you see how it took damage of 50, and I have remaining health of 10. Polymorphism is I'm still using that same die function, but I'm using it in two different ways. So now when I hit this one, which has the instant kill collider marked on it, I instantly die. See the starship dies. This is just a way that we can use polymorphism in the game to have different functions, or the same function act different ways throughout our game. And we can see even here on all the collider or all the components that we have assigned to these asteroids, they don't have health on them or the die component, so they're not gonna, like, it would throw an error because my damage on hits is looking for that. But because we have that statement in there that's checking to make sure that it actually has the death component, it's not going to receive any error. So we can see that our game works just as we had it before, where we can control using the WASD keys. We can teleport using the arrow keys. We can press T and it'll spawn in different locations. And then we can still move around and hit shift. So everything's, all we did is add on to it. So it was non-destructive for what we were working on. And we can come up and kill ourselves again. This is as far as I made it so far. I'm gonna be keep working on this, and we're gonna be making more advancements in here. I just added backgrounds and some more scripts to make it a playable, funner game. Thank you so much.